This video explains how to find the distance between 2 points on the Cartesian plane and how to find the midpoint of a line segment having endpoints on the Cartesian plane. We'll start with distance. Focusing on the diagram to the right, we have 2 points, x1, y1, and x2, y2, and we want to find the distance between them. We're able to form a right triangle from these 2 points. The distance between the 2 points is now the hypotenuse of the right triangle. We know that we can relate the 3 sides of a right triangle using the Pythagorean Theorem. We just need to find the lengths of the 2 sides. So to find the length of the bottom side, all we do is subtract our 2x values. And to get the length of the other side, the vertical side, all we need to do is subtract the 2y values. Pythagorean theorem then would say that x2 minus x1 squared plus y2 minus y1 squared is equal to the hypotenuse, which is our distance, squared. If we take the square root of both sides of that equation, we end up with our distance formula. So given 2 points, x1, y1, and x2, y2 on the plane, the distance between the 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. It's simply an application of the Pythagorean theorem. Let's find the distance between a couple pairs of points. We'll give the exact answer and an approximate answer rounded to the nearest hundredth. Just like when I'm finding slope, I always like to write x1, y1, and x2, y2 above my numbers so that I don't accidentally grab the wrong one. Now we're going to plug into our distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. We get our distance to be equal to the square root of -8 minus 6 squared plus 11 minus 4 squared. We want to clean up underneath of our radical. We get the square root of -14 squared plus 7 squared will be the square root of 196 plus 49, which is equal to the square root of 245. The directions asked us to give an exact answer and an approximate answer. So to get the exact answer, you want to simply simplify the radical. We'll look for the largest perfect square that's a factor of 245. 49 goes in 5 times. This simplifies to be 7 square root of 5, and that's our exact answer. To find the approximate answer, we'll just take the square root of 245 and put it in our calculator, and then round to the nearest hundredth. We end up with 15.65. Let's try another one. Let's find the distance between the points -5, 8 and -10, 14. We'll plug these numbers into our distance formula. I encourage you to write the distance formula every time until you have it memorized. We get our distance to be equal to the square root of -10 minus a -5 squared plus 14 minus 8 squared. This becomes -10 plus 5, so we'll have -5 squared plus 6 squared. That's the square root of 25 plus 36, giving us a distance of the square root of 61. For the exact answer, we just want to simplify our square root. Well, it turns out there's not a perfect square that's a factor of 61. This is simplified. This is our exact answer, square root of 61. We then want a decimal approximation. So we'll plug square root of 61 into our calculator and round to the nearest hundredth. We get 7.81. Next, we're going to discuss the midpoint formula. This is what we do to find the midpoint or the halfway point between 2 points in the plane. So if x1, y1, and x2, y2 are two endpoints of a line segment, then the midpoint of the line segment is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. I feel like this formula makes a lot of sense. The midpoint, the middle, it's the average. When you find average, you add numbers up and then divide by the number of numbers. The midpoint's going to be a point, so it has an x-coordinate and a y-coordinate. So we need to find the average x-coordinate by adding the two x values together and dividing by 2, and the average y-coordinate. Add the two y values together and divide by 2. So let's find the midpoint of a line segment given the endpoints. Our midpoint formula, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So for our x-coordinate, we're going to add 1 plus 5 divided by 2. And for our y-coordinate, it'll be -1 plus 5 divided by 2. That'll be 6 divided by 2 for our x-coordinate, 4 divided by 2 for our y-coordinate. We get a midpoint of 3, 2. Now remember, this is a point. Make sure you're writing your answer as an ordered pair. Let's find the midpoint of the line segment containing these endpoints. Midpoint formula. We're averaging the x-coordinates, and we're averaging the y-coordinates. For x, we'll have -2 plus 3 divided by 2, and for our y, we'll have 6 plus 4 divided by 2. This gives us 1 divided by 2 for our x-coordinate, 10 divided by 2 for our y-coordinate. We get a midpoint of 1/2, comma 5.